All right, well, welcome to Web Mapping with ArcGIS, Arcade Expressions. My name is Paul Barker. I'm a product engineer on the ArcGIS Online team. I work on a little bit of everything, from features, layers, to views, to offline, and coincidentally, Arcade. So we'll talk a little bit about Arcade. We've got Lisa over here.
Yep, I'm a cartographic product engineer on the Living Atlas team. I work a lot with demographic data in particular, so you'll notice a lot of my demos are about people in general. But I also use a lot of arcade mapping techniques in order to customize my maps beyond what data traditionally used to let us do. And so we'll show you a handful of those examples today. Quick question. Oh, yes?
It's hard to hear you.
Is it? Oh, all right. I'll put it on my necklace. I could also just talk like this. All right, that's fine. How many of you guys have used Arcade before? I love to see that. Great. And so how many of you guys have not? How many is this your first time ever? Great, good mix. That's what we like to see.
All right. Do you want to click the next one? So in terms of what we're covering today, we're going to talk about a little bit about Arcade, the language. We're going to talk through kind of a simple example where get started, write your first expression. Then we're going to go into why should you be using Arcade, and then give some a variety of different examples, and we'll kind of slowly increase complexity. We'll with some kind of easy wins and some simple stuff. I want to stress that you don't need to write a lot of Arcade to get a lot of value out of it. There are lots of easy things that you can do that really help kind of deliver a great experience to your users without really having to be an expert in coding. Testing and troubleshooting can be a little tricky at times, so we're going to cover some of the strategies on how you kind of start to debug. Unfortunately, with the Arcade editor, you can't just add a breakpoint and step through the Arcade code. It would be super awesome if you could. And maybe we'll do that in the future, but right now we're not there yet. So we'll give you some strategies on what to do in the meantime. And talk about performance considerations. One of the things with Arcade is it's incredibly flexible, incredibly powerful, and you can definitely write things that are irresponsible that will be really slow. And so we'll talk about performance considerations and kind of where to strike that balance between doing things on the fly versus calculating fields ahead of time. And so talk through some of that. And then we'll talk a little bit about what's coming down the pipe in the next kind of couple of releases and throughout this year. And Lisa's going to walk through, when you walk away and have all kinds of questions, where do you find the answers? So we're going to talk about some of the resources are available to you to learn and get familiar with Arcade, to understand what you can do. And so Arcade, unfortunately, is named after the architecture and not video games. I think we could have had a lot of fun if it was the other way around, but we've got a lot of languages at Esri that kind of have their roots in architecture, Avenue being one of them for anyone here who is old enough to have been around for ArcView 3. So what we intended to do was create a lightweight expression language that lets you work with your data. And what we really wanted to do here is give you something that felt familiar like Excel, but also brought in some of the flow control logic that you see in JavaScript. So you could do some really interesting things. And we really wanted it to be a cross-platform story so that you could write these expressions once and have them work everywhere across the ArcGIS platform. And we quite often get the question of, well, why didn't you guys just use JavaScript, or why not Python? And part of the reason is security. We wanted to be able to control that language execution so that we don't have to worry about injecting undesirable code. Python's a pretty heavy deployment on mobile devices. So we ultimately settled on writing our own language. And one of the things that we really wanted to put at the forefront of it is we wanted it to be geographically aware, which was kind of hard to find in some other libraries. So you can write, the whole spectrum. You can write, simple one-liner Arcade expressions. I've seen people write ones in the hundreds and thousands of lines, and so you can really kind of run the gamut on that in terms of complexity. I want to stress that it's not a replacement for Python or geoprocessing. Arcade is meant for lightweight, simple tasks, and it's really never going to replace the geoprocessing. In a lot of cases, it lets you do things on the fly so that you don't necessarily have to calculate a new field. So maybe you wanted to sum up 5 values in your attribute table and visualize based on the sum of that. You can do that really easily, really quickly. You don't have to calculate a field. And the benefit of Arcade is as that data changes when you're doing it on the fly, the expression will reevaluate and update. So you don't have to worry about Arcade being out of date, so to speak. We're going to switch it over to Lisa and write our first hello world expression.
I like to call it a hello world-ish expression because we see hello world all the time. I'll try to talk as loud as I can while this is on me. So this is the Arcade window as you would see it within ArcGIS Online. And by default, it says custom, and we really encourage people to give this a custom name because the way that you would name a field within your data, this is what will show up down the pipeline within like your legend and when you're searching for fields. And so we encourage you to, oh look, I've already called it Hello World-ish. And so we encourage you to use some sort of custom name for this. This right here is the expression window, and you don't have to know code to write Arcade. So if I just want to return the statement, hi, my name is Lisa, this will return the text string, hi, my name is Lisa. Simple enough. The language also lets you return a value. So if I say to return, hi, my name is Lisa, it will return that exact same thing. There's also variables, functions, a lot of different ways to work with this data. And so if I wanted to make it so that I want to be able to interchange what the name is, I can create a variable, var phrase, for example, equals this, but I want to exchange what name appears. I can say var name equals Lisa. And this right now won't return anything, but I'll say I want to return phrase plus my name. And so all I'm doing is saying, I'm assigning a variable, saying it's this text string, I'm assigning another variable, which is exchangeable, and then I just am combining those together. It's a simple concatenation so that when I retest this, again, it says, hi, my name is Lisa. If I want this to say, hi, my name is Paul, it's not. I would just exchange that. And if I want to be able to work with numerics, I can add another variable that's, say, age. And I can do things where I combine. Arcade is a lot less sensitive than Python. I know that with Python, syntax is very sensitive. And with Arcade, it's not quite as sensitive. And so if I want to say, what age am I can combine these things. I can say, and my age is, and then I can say, well, I don't know how old you are, actually. I won't ask. Plus age. And with Python, you'd have to convert this to a string, but Arcade is smart enough to say, oh, I see that you're working with a string, and it's going to go ahead and make that numeric value a string. So now your name is Paul, and your age is 24. If you're working with data that's not necessarily clean, there's functions that you can work with, a lot of different ones that work with either numeric or text attributes. And so one of the ones that's an option is proper. Within the Arcade window, you can search for the various different functions and learn more about each one. So it has built-in help. So as you're working with or learning about any of the functions, you can come over here and see what things apply to it. So this proper, I could proper case his name. If my data field was within my data and everything was lowercase or everything was capitalized, I could use proper to force this again to be a proper case name. And the combinations are kind of endless, and the functions cover a lot of things, but we'll go into those a little bit later, the ways that you can work with this. But what's nice is another way that you can work with these, just for an example, is if I chose something, when you click on this directly within the window, it'll tell you, it'll kind of auto-fill this in for you. And so any of these that you go to, if I had gone back to proper and I had just clicked it, it will add it in and tell you exactly what to do. This is where you would insert your field, and this is where, this is a definition that it defines over here as saying, do you want to do your every word or first word? So it kind of leads you through, and it's all contained within this window. And so that's just this is just a very simple example of the language itself.
And one thing to note too, in the March update, all of that help will be localized. So if you're an international customer and English isn't your language, we should be shipping that in all languages that we support in ArcGIS Online.
So why would you use Arcade? Like we had mentioned, there's kind of endless possibilities of what you can do with it, but it's because it's built on top of the ArcGIS platform, it makes it so that if your data is imperfect, because as we all know, data is not always perfect, it lets you really work with your data dynamically without having to go all the way back to the beginning and reprocess your data, recalculate a new field. There's a lot of customization options that are available, and it's all done on the fly, which, as Paul will mention, you can be a little, you can write expressions that are slow, and that's just because of the fact that it's built on top of it. And so we do want to be a little smart about the way that we're built, but in general, it's very quick as well, which is really cool because even though it's on the fly, the queries are extremely fast, and it's very easy to get started. And as we've mentioned, it does have this Excel-like structure to it. So if you want to just add two variables, you just click the variable, plus sign, click the other variable. And so you don't have to be a programmer to be able to work with Excel, because it's, like he mentioned, it goes through, it's all ends of the spectrum. Again, as he mentioned, it's secure, and it's also geospatial. And by that we mean that there's geometry functions built into it, meaning that you can work with your features, and you can do things like calculate area on the fly. You can do things like intersect. And so there are a handful of geometry-based geospatial functions built into Arcade that let you do things that, again, make it so you don't have to go back to your original data and recalculate something and rerun a process. And so it really helps it make it flexible. Again, a lot of this we already covered. You can write basic calculations. You can use the built-in functions. There's a ton of them, and they're extremely useful. And I'll show you this later. You can reuse existing expressions once you're in a web map. So if you've used an expression once, you'll be able to quickly access that expression again and be able to reuse it, so you don't have to retype it each time that you're working with it. Some examples are you can do field formatting, you can combine fields together, you can do if-else statements, you can do unit conversion, you can rotate symbols, you can improve your text labeling, and we'll show you a lot of these examples actually. For example, if you just want to calculate a percent, again, if you're familiar with Excel, this has that Excel-like structure to it, where all you're utilizing a function, you're telling it which fields within your data that you want to access, and you're just writing a basic equation by saying, I want to do this field divided by this field, in parentheses, times 100, I'm calculating a percent on the fly. So this is the expression, as we said. Globals, that's where you access the fields within your data. Functions are the list of functions that you can access, and then constants cover things such as, pi, different basic mathematical constants. And once you have actually created an expression, again, you can access your existing. And so, like I said, it's all contained within there. There's also that test button that you watched me use, and that is our version of troubleshooting. And so use that as much as possible. If you run into an error, it will give you a pretty comprehensive error message that's saying, this line isn't working. It'll put an X by the part that's not working. And while, like you said, we don't have breakpoints and whatnot, it is pretty comprehensive in the way that it tells you what's not working. Within the web map in ArcGIS Online, there's lots of different ways to use Arcade. You can use it to set your symbology. You can set it to rotate your symbol. You can use it for transparency. You can use it for pop-up configuration, which actually has a lot more functionality currently than all of the others, but we'll go into that near the end in the Get Fancy section. And you can also do labeling. And you'll notice in each one of these that when you're accessing, the way that you access your fields within all of these different places in a web map, if you scroll to the very bottom, it'll say new expression. And that's how you get to that arcade window that we showed earlier. And so whenever you want to calculate a new value on top of your data, you would choose as you would a normal field, but go to the bottom and choose that new expression. And now Paul's going to give us
All right.
our first demo within a web map.
Okay, so some of you might not know this, but I like to survey turkeys all over the world. This is a fake data set, but it's good for kind of showing. So turkey surveys are actually something a field biologist might do, but probably on a much localer scale. And if I click on one of these guys, you'll see there's not a lot of information. We've got the town name, but we do have different counts. So for the different types of observations. So we have hens sighted with poults, and hens without poults, as well as poults by themselves, which are baby turkeys, and toms and jakes, which are the male turkeys. So if you were doing this in the field, as the data comes in, you might want to know the total number of turkeys per observation point. And so that data may change over time, and you might want to visualize that. So what you can do in Arcade very quickly is create an expression in the pop-up and have that calculated on the fly. And the advantage to doing that over a traditional field calc where you would just add those together is that it's dynamic and it stays up to date. So as your data changes, this continually updates because it's evaluated at the time that you're viewing the map, not stored against the data. So if we went in here, like Lisa was saying, we can come down to configure pop-up. And if you scroll down, you can see attribute expressions. And if we hit add, we can come in here, get rid of the helper text, and say, let's call this total turkeys. Give it a good name. Giving it a good name makes your life a lot easier later. So I'll get into this later, but depending on the layer that you're using or where you're using Arcade, you may see the left panel of the globals look like this, where you've got this dollar feature, dollar layer, dollar data store, dollar map. And I'll just take a quick second to explain. So dollar feature means that it evaluates information for that active feature. So in the context of the pop-up, when I click on the feature, dollar feature is that feature. Dollar layer lets you access other layer, or the entire layer. So if you wanted to loop through the layer looking for something specific, you could reference it that way. You could also choose to reference it with dollar data store, but dollar data store lets you work with multiple layers within the same service, and dollar map is very, very similar, except that it's in the context of the map. So we'll get into how to use those in the later section, but so sometimes you will see, oops, sorry, I'm going to click the arrow there. Sometimes when you start the editor, you'll see something that looks a lot more like this, where you have a list of the fields on a given feature versus the other one. So just to be aware. But if I want to add these up quickly, I'm going to go through and add these quick. And let's scroll down. Toms and jakes. And last but not least, where's toms without jakes? Oh, sorry, poults was the one I was missing. So if I test that now, it's going to go through, it's going to query, it's going to add all those up, and so we got 25 for that particular feature. So the test feature, are you going to show the test feature later? All right, I'll show it right now. So when you're in the Arcade editor, you can test your expression. And how that works is you can fill in, we auto-populate test data for you based on your layer. So it'll pick the first feature of the layer. If you want to test specific values for given fields that you're using, so you can hit the little edit button over by each field and change the value. That's not editing your data. All that's doing is changing the test feature. So if you've got some conditional statement and you want to test both sides of the equation, you can change that to test to do that additional testing. But let's go back here and just finish this off. So if I click on my turkey now, you'll see that I have total turkeys are 20, and I've got 2 lovely decimal places, which probably doesn't accurately represent turkeys. So I could use a round function to round that to an integer, or I could use the pop-up formatting to drop the decimal places. All right, back over to you, right, Lisa?
Yep. I'm going to give you guys a quick resource while we're going. There is a blog on the ArcGIS blogs page called Use Arcade Expressions to Map Your Ideas. There's a lot of different. This is a really good place to start if you want an intro when you get home, and I know you guys will be flooded with information. This gives you a quick intro of what we're showing today. It also contains a lot of different examples. And so when you go into here, there's a group that's been pre-populated with a bunch of different web map examples that use Arcade in some sort of way. And so it'll bring you to this ArcGIS Online group with all of these examples. And for example, this population change map, if you click on it, it'll bring it to you to show you what that map looks like. And if you want to explore those Arcade expressions, click the Map Viewer button, which will bring you to that web map. And so for this example, Arcade is being used to visualize the data. So if you went into the visualization options, you'll see this little pencil. Whenever you see a pencil, that means an Arcade expression. And so if you wanted to explore the Arcade expression that was used, you could go in here and see what was done. If you're just looking for examples, ways to use Arcade. So I'm actually going to step you through making this map, which is change of population from 2000 to 2010, but the data, as I'm accessing it, only has the data as 2 fields. One is the 2000 figure and one is the 2010 figure. And so using Arcade, instead of having to calculate a field, we're going to do this on the fly. So so I'm actually accessing a layer from the Living Atlas. This contains 2010 census data in it. And so as it is, like I said, it has 2 different fields, a 2000 population figure and a 2010 population figure. But I'm going to scroll down to the bottom and go to New Expression to symbolize a different combination of those using an Arcade expression. So we're brought to this window that we're familiar with at this point, and I want to calculate the change in population from 2000 to 2010 as a percent. So that equation would be new minus old divided by old. Sometimes I like to type it out like this first, just because it helps me kind of build it as I go. If I want it as a percentage, I would multiply it by 100. So I'm kind of setting the scene. I essentially just wrote out the formula that I want it to execute. And so now I'll go through and add in the fields from my data that fit this formula. So first I would find new, which was 2010 population, and I would click this feature and it automatically adds it directly into my expression. And I can do the same thing with my old, where I fill that in just by clicking the feature. And so right now, again, as you mentioned, $feature accesses those 2 separate fields, and this on the fly is going to calculate me a beautiful percent change value, which will be symbolized within my map. But as you can see, this value is quite a few more significant figures than are really necessary. So in the functions, there is the round function, as he mentioned. And so this says, give me the value and then tell me how many places you want to round this value. So I could say, okay, I want to round this to 2 figures. And so now when I test this, I'm getting a number that's a little bit more manageable within my data. So this is going to be returning me a number with this example. And once you click OK, ArcGIS Online Smart Mapping will say, oh, okay, Arcade is giving me a number. So it's going to give me options for mapping based off of the fact that it knows this is a count or amount. By default, it's giving me the size, but I would want to map these by color so that I can visualize the pattern. I can go into my value, and really it's just accessing that percent that I calculated just as it would calculate any other field. And so in this case, these numbers don't really mean a lot to me, so I could use the above and below, center it on 0, and I really just want to see plus or minus a 10% change in population in the country. And in just a few minutes, you can see that I'm now mapping change in population, and this was all done on the fly, sitting on top of the data that already exists. I don't even own this data. This is from the Living Atlas, and now I have a brand new map of change in population in my area. And now Paul's going to show you a few more examples of what you can do within the web map viewer using Arcade. This is just symbology.
Yep. So I'm going to show a labeling example. I guess, show of hands, how many people would really like to have multi-line labeling? All right. You can't have it everywhere just yet, but you can have it some places. So let's walk through an example. You'll notice I'm in the map viewer right now, and I don't have multi-line labeling, that's for sure. And that really, like when we move the map viewer to the 4x JavaScript API, we'll get multi-line labeling, but it won't come to the 3x API. So if I go in and I look at labeling, I'm doing, and kind of like Lisa said, you'll see the edit button by the expression coming in here, and there's a lot more going on than just a simple label at this point. So I'm actually doing a little bit of conditional labeling. So I'm actually only labeling crab apples and silver maples. But what I'm using is the split function based on the name, and I'm splitting it everywhere that there's a space. And then I'm returning the first instance, so the first piece of the name. So in crab apple's case, it's crab. And I'm inserting one of these constants that Lisa talked about earlier, a new line character. So we do support in the 4x API. So any app you build on 4x for the JavaScript, we do support this. So I'm returning the first word and the second word, squeezing a new line between them. And if I come over and actually shared that to one of our newer app templates written on 4x, you'll see that I get multi-line labeling. So it's not everywhere as yet, but if you really need multi-line labeling, you can strategically use one of the app templates from the configurable app templates that are written on the newer API. Write your expression, and you'll get multi-line labeling. Pretty cool, I think. But so let's hop back and look at some other interesting stuff. Anybody from Ontario, Canada?
Represent.
So this is our water well data set from the Ministry of Environment. There's a lot of water wells. I'm just going to zoom in, and Lisa is probably angry at my cartography, but it's not the best. Okay. But it was a really dense data set. But you'll look at the pop-up. I'm going to show the pop-up, and I've taken the time to format a pretty, aside from the rounding issue on depth to bedrock, I've got a pretty nice looking pop-up. I've got some summary information. I'm leveraging some text formatting in the custom pop-up. And it looks like a normal pop-up, but it's actually using quite a bit of Arcade to do some interesting things. So the drilling depth and depth to bedrock are actually, depth to bedrock and static water level both are actually done using an Arcade expression. And I'm actually using some string functions to dynamically build a URL to the PDF paper well log that the Ministry of Environment makes available. So if I click this link, which is built dynamically in Arcade, and we'll take a look in a second, I actually get the original water well record. So it's because the URLs are a pattern based on the well ID number in a well-known kind of schema, so you can actually build it dynamically. So if I go to the pop-up, let's take a look at that one first. It's paper well logs one. And so what I've done is I've taken my base URL here, and I'm just concatenating some things together. So their naming pattern is they have kind of a, part of the URL is made up of the first 3 digits of the water well's ID. So I'm using left, telling it to grab the first 3 digits for the field that is well ID. I'm inserting my slash for my URL, and then the PDFs are actually based entirely on the well ID. So using Arcade, I can build that dynamically on the fly and provide that information to my user inside the pop-up, even though that data doesn't exist in the data set. And depth to bedrock and static water level, I'm doing something a little, just to tidy it up. So in this data set, not recorded is stored as 0 because it's a database and they don't want to mix strings and or in numbers. So that could be confusing to somebody who's just viewing that information. Does depth to bedrock 0 mean that it's at surface, or does it mean that it's not recorded? And in this case, it's not recorded. So what I'm doing is looking at the value of that field, which is this one, the DP bedrock. And if it's 0, then return not recorded, so that it's very clear to the end user that that is the case. I'm doing the same thing for static water level as well. So, and the way that we've done this, I'm using a custom pop-up. And if we go into the custom pop-up, you can see, if you're familiar with doing this, you'll see these, the squiggly brackets and the field name. Referencing arcade in your pop-up works exactly the same. You reference it based on its name, which happens to be expression/something. And if you hit this little plus button down here, you'll see, you can scroll to the bottom and you'll show, so if you're looking for which one's the right one, you can just see it and insert the one where you want. I know some people have asked, why is it such a cryptic name? We do that for uniqueness, to make sure that we can control that you don't wind up with 2 expressions that are called the same thing, and to keep it kind of concise. So I realize that expression/expr1 doesn't necessarily tell you a lot, but anywhere you add it in through the user interface, we do inject the title of it so that you know what you're dealing with. I think that's it for me. So those were some basic examples, and so we'll start diving into some more interesting ones. And take it away.
Yeah, so in our Get Fancy section, so what we've shown you so far is just some basic functionality of what Arcade can do. The fact that you can dynamically calculate new field attributes on the fly, but they're not stored as attributes. Like he mentioned, the fact that they're dynamic and they'll change with your data if the fields it's using are changed. So with Getting Fancy, this is where we'll kind of start to explain those variables that I showed in the beginning. The fact that you can build your own functions. There's Boolean logic. True. If something is true, do something. If something is false, do something. We have things such as for loops, conditional statements, the geometry functions that I mentioned earlier, and feature sets, which Paul will explain in just a second. But for example, if you noticed in his last example, he said, if something, do something, else, do something else. There was a function called if, and it did that for him. And all that's doing is utilizing a conditional statement. So you're just going that one step further rather than saying this plus this. You're looking at your data attributes and it's making decisions on the fly within Arcade. For example, where you access related data in your pop-up, which I believe that's what he just showed. You can write complex calculations. So you can calculate an index for multiple fields, or you can render based off of geographic relationships of 2 different attributes.
Just one quick thing. Sorry, my mic's off. One quick thing to call out about rendering based on geographic relationships. You can only do that if you actually use Arcade to do a field calculation. I know everybody in this room would probably love to be able to dynamically theme based on related records and define an Arcade expression. The reality is it will be way too slow and it will not work. So we do, like for the calculate, when you're using feature sets to render, you do have to pre-calculate that field. And I'll talk a little bit more about that later. Okay. All right, is this me?
Yeah, that's you.
All right. So what is a feature set? So, I mean, it's exactly what it sounds like. A feature set is a set of features. So that could be features within the layer that you're currently working with. It could be features in another layer. It could be related information. And so it doesn't really matter where it came from. It's just a group of features that you can iterate through. And so like, don't get too hung up on it, but they're really powerful, and you can do some really cool things, and hopefully we'll show you some of them. But you do need to use them responsibly. You can get to a point where Arcade expressions are taking 60 seconds to execute, and just like that's not going to create the user experience that you want. And so Just keep that in mind.
And I'll just interject real quick. The way that I think of feature sets in its most simplest form is the fact that, so if I have a layer and I'd really like to use something from another layer within my map, traditionally you'd have to do a join, connect those data sets, do that pre-processing that we were talking about. Think of a feature set as being able to access another layer and interact with data that's on a completely different, feature service on the fly. So when you are accessing a feature set, like you said, it's a set of features just within a different layer within your map. It does have to be within your web map in order to access it. So you'd want to add the other layer in your web map, and then you would access it as a feature set. And that's how you'd be able to calculate new things by interacting with that other layer or feature set. So, sorry, that's just the way I thought of it to kind of simplify it. It's just other layers.
All right. So, while we're going to talk about this in some detail today, I would encourage both of you to check out the blog site. We've got 2 blogs that I wrote in December that talk through feature sets conceptually, how you might want to use them, as well as some of the material that we're covering today. So if you want a refresher when you get back to the office, it's a 2-part blog series. It's got examples, it's got code snippets for various things. And that's the example that I'm going to talk about now. So it's a good reference point for the conference. So let's switch over to the map viewer here. And what you're looking at is the City of Toronto's urban forestry inventory, as well as their neighborhoods. So you actually can't see the urban forestry until you zoom really far in. But what we're doing is, you gotta go really far, I guess. There we go. Is we're using Arcade to provide information about the trees inside the neighborhoods pop-up. And so when that's done strategically, you can create a really great experience, because it means that I don't have to have the tree layer on, I'm not clicking and going through multiple pop-ups at the same time. So you can strategically pull that information into one pop-up to kind of make a better viewing experience. Another example, say maybe you had parcels and buildings, and you wanted to show the number of buildings on a given parcel. You could actually use Arcade to do that dynamically and insert it into the parcel layers pop-up. So if I click on a neighborhood right now, it'll probably be a little bit slower than it normally is because of the Wi-Fi in the Palm Springs Convention Center, but you'll see a bunch of information pops up. And so we're in the neighborhood of Willow Ridge, Martin Grove, Richview, which is quite a mouthful, but and what you're seeing in the bold there is a number of things being pulled from the tree layer. So I've clicked on the neighborhoods layer, but I'm getting information about the trees, which is pretty cool. So it's telling me that the neighborhood has a total of 7,539 trees. I roughly calculate use the area of the polygon to calculate a rough density. In my particular case with this data set, I have to be careful because there are parts of Toronto where they haven't accounted for water. So by the Toronto Island area, that calculation would be inaccurate. So you do have to be a little bit careful and think about your data and whether it makes sense to apply those calculations. So in the context of kind of the mainland, it's perfectly appropriate, but maybe not without a little bit of cleanup on the coastal area. And what I'm doing is also passing a filter into the tree layer and just trying to figure out how many of those trees are within that neighborhood are maples. And so this is all done using feature sets, and that's how we access these layers. So we'll dive into the pop-up here and take a look at a few of them. So the simplest one is probably the number of trees. So we'll start there. And so what I'm doing here is creating a variable, like Lisa talked earlier, but that variable is going to host a feature set. And so there's multiple ways that you can define feature sets. You can do it by the layer's ID, you can do it by the service, you can do it by name. Name is the most readable, but you do need to be aware that if you start renaming things, your Arcade expressions will break. So if you think you're going to spend a lot of time renaming your layers, maybe use the ID instead, because the ID is static. So there's options there, depending on your use case, but my general strategy to you would be if you can define it by name, because your titles are good, then go for that. It's the most readable, it's easier to come back to. And so what I've done, I've defined my feature set, and all that is a group of features, and I'm using the reference of $map. So what this really means is I'm saying in the web map, find the layer that's named urban forestry. And in this particular case, I'm getting all the features. And what I want to do now is use my count function. Well, first actually, let's go on the inside. And so I'm saying, okay, I want to do an intersect, and I'm going to take all of the trees, which we defined up here, and I want to intersect it with the feature. In the context of this, $feature is the neighborhood polygon I clicked on. And once I've done that, I want to chain it with a count. And so what that's going to do is look at all the features that came back from that query that eventually gets run and just get the count. And we're trying to be really smart under the hood about how we query this data so that you guys can do really interesting things and still have it be really fast. And I'll talk a little bit about how Arcade executes those queries later. And then all I'm doing is returning that variable. So it's a simple case. There's no filtering. I'm just doing an intersect and a count, but I'm doing it all on the fly. I didn't have to create a new layer, duplicate data. It stays entirely up to date as the tree layer changes, which is, yeah, pretty neat. And then if we look at the trees per square kilometer, you'll see a little bit of repetition. Doing the same thing, defining my feature set. I'm getting the count, and then I'm looking at the geodesic area for the neighborhood and calculating the tree density and rounding it to 2 decimal places just to tidy it up a little bit. And then last but not least, number of maple trees. So this one, querying, you can pass a filter, which is really useful. It takes a little bit of getting used to, but very similar pattern. You'll see that one of the design efforts we're going to be doing over the next year or so is to redo the Arcade editor. And one of the common requests is to make the code window much, much bigger. So you can see that these can get a little bit long once you start kind of chaining them all together. But basically, I'm just defining that same feature set. I want the for urban forestry. And if you look we go to the left, I'm wrapping this on the outside with a filter command. And the filter takes the feature set, and I'm passing a SQL92 query into it. So I'm saying for the field, common name, I want to filter based on anything that has the word maple with a little bit of the wildcard searching. So this is going to go through and look at the common name for each tree, and if it matches that pattern, it's going to return it in the feature set. And then I just do the same thing as before. I intersect it, and then I get the count and return the count. And so I'm left with only the trees that have maple in their name, basically.
And real quick, when it comes to performance, if you are able to do an attribute filter, like he just showed, that is in general faster than the geometry, intersects and whatnot. And so if you're able to do a filter, that's a really good way to speed up the Arcade statement so that it is quicker, which I'll cover later.
Totally. Anytime you can, we'll get to strategy, but anytime you can reduce beforehand. And we'll talk about a little bit later about how the query execution plan is trying to be as smart as possible. But I think over to you.
Yep. I'm going to go back to that group just so that you guys may be able to go back home and look at these examples again later. This is that group, and in here there's this emplanements example. And if we go into that map, this is actually using Arcade to calculate something that's changing the rotation of your symbol. So again, I'm going to go into the settings, and I'm going to explore the Arcade statement, that was used for that. So the option to rotate the symbol, usually you can choose a field, but in this case, we did an Arcade expression. And so I assign a variable, do a basic calculation of the most recent employments, how many people have boarded planes in 2011, minus how many people have done it in 2001, just to see if there has been an increase or a decrease. And so all I'm saying is that if there was an increase, return an angle, a positive angle, and then if not, return a smaller angle, so that the way that you choose whether or not it's a geographic or arithmetic angle, this is just going to use those two attributes to change the angle that this is using. So this is just a small little cartographic technique that you can use actually, so that you can see that if there was a decrease, these red symbols are kind of almost pointing down a little bit. And then if there was an increase, it's using that angle that we're calculating to show that there was an increase. So that's why the little planes look like they're pointing up. So you can see, just quickly visualize patterns to see interesting things based off of something that's calculated on the fly with two different attributes. And this is more of one of those little cartographic tips, but I like to throw it in there. Another example that's shown within this group is solar potential in Bristol. And this example is just, again, utilizing different fields within your data to set conditional statements. So in this case, I'm saying if my feature is under 3,000, if I'm getting less than 3,000 kilowatt hours, I want that to be classified as low. If it's in between 3,000 and 5,000, I want to give that as average. And if it's higher than 5,000, I give it, I return high. So you can see that I have three different if statements here. And it's going to return me whichever value this conditional statement applies to. And so you'll notice that these are returning me text values. So in comparison to a lot of the examples that we've shown you so far, what this does is it's going to return a text string. So when I test this, it's saying, okay, here's your example. This is going to be giving you a text string, so that when you write a statement that returns a text string, ArcGIS Online Smart Mapping will say that's a unique value. And so in this case, this is giving us a classification, a unique symbols classification. And then we just use colors in order to easily show if this is in some sort of condition, rather than just giving a range, a high to low numeric range. And so this is just another different way to visualize your data. You know, you could use a high to low pattern using counts and amounts. And this is just a different technique if you have, if you have to show things within these different categories. And so these, again, are just some quick little tricks that utilize conditional statements. So it's just going that one step further than a basic calculation if you want to, quote unquote, get fancy. Right. I'm gonna go back to you.
Yep, I got one more. All right. Wow. I apologize for the contrast, guys. If you squint and kind of turn your head sideways, you'll see some police precincts there. Let me change the cartography here really quick. Picking up that line so that what I've got here is some crime data and police districts. Turn off adjust automatically and let's make it there. Yeah, that'll be perfect. Okay. So you can sort of see it now. I apologize for the quality, but so I've got some crime data, I've got some police precincts. This data is not, formally related, but it is spatially related, similar to the tree example. And what I'm going to show you is kind of how you can summarize information in the pop-up and leverage some of that text formatting. So if I click on a district here, and I look at crime summary, what it's actually doing is pulling me a list of all of the unique crimes within that police precinct polygon. It's keeping track of how many incidents there were per polygon. And then I have an additional one that looks at all those values and actually tells me what the top crime per police precinct is. So I want to call this one out for a few reasons. It uses some of the new formatting we added in December, but it's also an example that is reasonably expensive to do. And it works in my particular example because my data set isn't very big. If I tried to do this on the City of Toronto tree layer that had 500,000 trees, it would be a lot slower. And so this is actually, we'll break down the expression just to look kind of quickly at what it does. But this is an area we, in the future, will make discrete functions for so that we can query really efficiently so that you can do things like this. So what I'm doing, I'm gonna take this guy out because he doesn't need to be there. I'm defining an empty dictionary, setting a counter, and some empty string variables. And very similar to the tree layer, I'm basically intersecting my police precinct with my crimes layer. This time I happen to be using data store because these two layers are within the same service. So I can actually reference it via the service if I want to. I don't have to. I've just chosen to for this particular example. So I'm intersecting, which gives me a feature set of all of the features, all the crimes that are intersecting that precinct. And what I'm doing now is using a for loop to loop through all of those features. And every time I loop through a feature, I keep track of whether I already have it in my list. And if I already have it in my list, I just count and add one. And if it doesn't, if the crime category doesn't exist in my dictionary, I add it and set it to 1. And then at the end of the day, so that's what's happening all in this for loop. It's building that dictionary. And then what I'm doing afterwards is looping through that dictionary to figure out what I want to return. And all I'm doing here is going through each entry and concatenating some things together. So in this particular context, K is the crime category, and used K is the number. And what I'm doing is after each kind of key value pair, I'm inserting a text new line and just continuing to concatenate that string together as I build that list. And I finally return the full list. And because the pop-up supports that new line character, you see it reasonably formatted in the pop-up. And that's an area that we want to do more in the future. We've heard from lots of you that you really want to be able to do some formatting. And so we are kind of exploring that option. And you may find that with something like this, you may be able to, instead of returning a string, just return the dictionary to the pop-up, and the pop-up will be smart enough to format that appropriately. So there's a lot of things like that that we're looking at to kind of make your life easier so that you don't have to do things like this. And for building this list, you'll eventually see like a distinct function come in where you can just say, I want the distinct features and the count for this particular layer. And that query is incredibly efficient compared to what I'm doing right now. So just an example, this would be a poor example to approach today with data of any size. It would be slow, and it will fire off a lot of queries. But the theme of responsible arcading, I'm showing it. All right.
Speaking of which.
Yes, I think we've got to what's next, troubleshooting?
Yep.
Yeah. All right. So when things go wrong and you get errors, what do you do? Like I said, we don't have breakpoints. I really wish we did, and we might in the future. But one of the most important things you can do is plan. So like Lisa was showing earlier, she wrote out that rough expression. It stubbed it kind of out in pseudocode before she got to actually writing the expression. So take some time and think about it. And leverage the test feature heavily. It's one of the few ways that you can actually test all of your conditions inside of the editor. So if you're using, we have a when function, which is very similar to a case statement, if you're familiar with case statements. If you wanted to test all of those conditions, you can use the test function and editing that field value to cycle through all of those scenarios just to make sure you've got it right. We also have a log statement. So there is, here, if I pop back over to here and search for, oh, sorry, yeah, maybe we can pop over. So there's a console statement that will let you log data out to the, so if I hit test right now, you'll see results and you'll see messages. The console function lets you put messages here. So if you're trying to stub through some problematic code, you can add those log statements in, find out where and what is executing properly, and help kind of narrow that down. You can switch back if you want. And like anything, if you find that you've got a set of logic that you're reusing multiple times, you do have the ability to factor that logic out into functions. So you can define your own functions within Arcade, within that expressions window, and you can reuse those. And that's handy because it kind of logically groups the code together. And if you're trying to comment things out to test different scenarios, then it kind of helps keep things organized. Last but not least, considerations. If you're when you're testing these, you can look at, open the Chrome debugger and see all of the network traffic that's kind of getting sent with your expression, and that's a good kind of litmus test to know whether you're being responsible or not, and whether it's going to come back in time. Like Lisa said earlier, whenever you can, filter your data first. There is no point looping through 5,000 features when you only need to loop through 10 to get your answer. So attribute queries will always be faster than the spatial queries. So when you can use that filter function to send that query in advance, do it. And one thing to call out, if you don't need to be querying or accessing that data, then don't request it. So by default, feature sets will request every field. You can actually, I didn't show it, but you can actually specify specific fields only. So if you got a big data set and you really only need to work with one field, you can actually say, I want to define that feature set, and only the object ID in that field will come back. And that will help kind of squeeze a little bit of extra juice out of it. And chain functions. So Arcade evaluates feature sets in a lazy way. And what that means in practice is until it's really used, it all gets stacked together. And when we can send things together, we do. So if you had, a count, a filter, and an intersect, and you weren't doing things with it in between, that actually gets sent to as one query. So it's more efficient that way. And in that part 2 of the blog series I talked about earlier, it talks a little bit more about that and how that works and kind of the differences in patterns. We're definitely out of time to dive into it today. Yeah. Yeah, in terms of what's next, I'm going to show one quick demo if you guys want to be beforehand. So one of the things that we're working with in Arcade for either the upcoming release or the next release is the ability to access attachments via Arcade. And Jeremy showed some of that in the plenary, but it actually lets you do some pretty neat things. Like you could define conditional logic to calculate a field. This will only be in the calculate profile, I guess, to qualify, but you could calculate a new field that had an expression that said, you know what, if I was doing damage assessment and the building was damaged, does it have a photo? And basically loop through the attachments for a given photo while using conditional kind of expressions. And what you can do too is get access to the metadata for the actual attachment. And so I'm showing a bit of a hack here, and it works under a few caveats, but what I've done is I've calculated the attachment ID for each feature, and it works for me because the data is public, and I only have one attachment per feature in my particular case. But what that allows me to do is dynamically build a thumbnail URL for the attachment, as well as the link to the actual attachment. So when I click on a feature here, I see a thumbnail. It's only 300 wide, so it's pretty fast and light. It's not the whole attachment. But if I click on it, kicks me out to the full resolution image. And so we're going to make this easier in the pop-up in general so that you don't have to do any of this, but it allows you to start to do interesting things when you can access the attachments. There's a number of things that we're doing with feature sets to simplify workflows. So when you have a formal relationship defined with the data, we want to make it easier to access that related data and just say, I want a feature set based on the related records for this feature on this layer. And so right now, the way that you would do that is you would look at your feature, get its primary key, send the filter, define a feature set from a filter to the related layer, and get back only its related features. So we're going to make that, rather than 3 or 4 lines, we'll make that just one call in the future. Yeah, we're going to add lots of functions to make your life easier. One of them being like the distinct one that I talked about. We are looking at URL, URI encoding options too. So a number of you guys have been building URLs that happen to have spaces and funny characters. And right now, it's a tremendous amount of work to get right when you're in that scenario. If you've got simple URLs, it works really well. So we're actually going to have some functions in there that you can pass it just a plain text URL and it'll encode it on the fly for you so that you don't have to do that. We do have a longer term project. It may not be this year, but we are looking at revamping the Arcade editor. We want to do more there. We want to make it easier for you to debug. We'd really like to have like IntelliSense and auto-completing things, and generally making it easier to access things, or particularly when it comes to debugging that test feature, we want you to be able to pick which feature in your data set you want to use as the test feature and browse for that and different things. So we've got lots of good stuff. It's continually adding things each release, so be sure to keep it. Yep. So the question is, can you do the same stuff and have it trickle through into apps like Collector? It's not always 100% in sync. I would check with them exactly what the ArcGIS runtime supports, just to be clear. They support a lot of what we support on the web, but it's not exactly a one-to-one. So there's a few little things here and there that probably will not work, but they would know better than me. All right, so we've got, we're over time, but Lisa's going to show you 2 quick slides, and then we can take some questions.
Yeah, so this page has a lot of different resources. There's blogs, there's a story map tutorial to show a step-by-step example, there's the documentation, there's GitHub arcade examples between online, in ArcGIS Online and JavaScript examples. And there's also an ArcGIS Online group, the one that I showed you earlier. And instead of giving you all of those links, we give you one easy link, which is esriurl.com/arcade resources. And so you'll be able to get to this slide and click on each one of these if you want to access additional resources. It covers really a lot of what we've already shown, plus a lot more. We really encourage you guys to go to the blogs pages because those contain a lot of just real-world examples, a lot of step-by-step tutorials, and a lot of your frequently asked questions will be answered in blogs or the help pages. And to be honest, the documentation for Arcade is very good, and there's a lot of different samples, and so we really encourage you guys to explore those when you're getting started. And then we just want to say, if you want to learn more about Arcade, there is a session tomorrow morning about pumping up your pop-ups with Arcade, really just making really comprehensive pop-ups. We're going to cover the feature set capability. We'll also go into a few different examples of utilizing HTML with Arcade together within the pop-up environment in web mapping. There's also an ArcGIS API for JavaScript using Arcade in your apps presentation tomorrow by one of our teammates, and we would really encourage you, especially if you're writing JavaScript applications, to go to that session. And that's it for us. We encourage you to take the survey online.
Yeah, please take the time to fill out the survey. We do spend a lot of time reading them, and we want these sessions to be useful for you. I mean, that's why they exist. So if you have feedback, positive or room for improvement, please share that. And thank you very much, guys.
Feel free to come up and ask questions.